Hi class, let's take a look at chapter 1, and we're going to be talking about a couple of definitions that you're going to see throughout the semester and also chapter 1. So let's go to the first one. So statistics. So technically statistics is not a math class. What it actually is technically science and the proper way of conducting studies. So the basic definition is as science of planning studies, the proper way to doing any sort of data collection process where the main idea is that we get to draw conclusions based on the data. So you're looking at somehow collecting data, doing it properly, and then making predictions. So the main idea in our class is that the data is going to be already given. Based on that data set, we will be doing predictions. Now, let's take a look at exactly where we're collecting the data. And here is what we technically have. So you're technically looking at a population. So you're looking at a population, and as you look at the population, you may not be able to get data from the entire population because it may be infinite. You're only going to be able to get some samples. So the basic idea for the population is everyone that the researcher is trying to actually survey or collect data. And an example for a population could be community college students. Now, a sample from them, well, in this case, is a subset. So for us, it would be MJC students. Now, think about population and sample in the following form. It may not be possible to collect data of the entire population, so therefore we have to get a sample. So think about if you had to get a blood test. They couldn't take all of your blood out because that will prevent you from living. What they would do is they get a small sample. Based on the sample, then they can tell you if you have a specific condition. So you're always looking at any one of the sections in terms of is the data that you're given a sample or a actual population. Let's go to the next one. Now, these are the symbols that we're going to be using for the rest of the semester. And it goes technically back to the previous one of population or sample. So sample or population. And this is what we technically have. Whenever we talk about the mean, you have to keep these two separate. Do you have the mean of a sample? If you have the mean of a sample, then the proper variable is x bar. If not, you have a population and we call that mu. Now, we'll talk about what the standard deviation and the variance means in chapter 3. So if you have the standard deviation of a sample, in that case, that's going to be defined as S. If it's a population, that would be sigma. For the variance, if it's a sample, that's going to be automatically S squared. And for a population, it's sigma squared. Proper formulas will be given later in chapter 3 actually. Now, let's talk about the branches of statistics. So for the majority of our class, we're going to be talking about inferential statistics. That means that we're going to be given data. Based on the data, we're going to be drawing conclusions of the population. And descriptive statistics deals with proper ways of data collection. So in summary, there's basically two branches. Descriptive deals on how do we conduct studies, and then once we have the proper data, then inferential deals with creating inferences on the population. Let's go to the next one. Okay, so the following are going to show up in chapter 1 and throughout the semester. If they mention a census, in this case, well, it's the idea on a census is that we're trying to get a numerical value of how many individuals we have in the population. So it's the collection of every one of the members. And we're mainly looking at the total. Now, whenever they mention in a problem for the future that a given value is a parameter, in that case, that's a measurement of the population. So you automatically know that you have a population. And let me go back to the previous one. So populations, these will be the variables used. Samples, those will be the ones. So for the one that we left off, if it says parameter, it's a measurement of the population. If they mention a statistic, it's a measurement of a sample. So a little bit confusing on those two, but the data values that we're going to be given, they're either going to say we have a sample or an actual population. Let's talk about data. And this is what we're mainly going to be analyzing. So for us, we're basically looking at two types of data. Now, if the data given, you can actually run calculations. In that case, it happens to be qualitative data or numerical data, anything that you can actually evaluate and obtain a number. So for example, you can look at salary of students, you can get the mean, standard deviation, a maximum or a minimum value. You can look at age of students, you can see what would be the mean age of our classmates. And if they mention categorical data or qualitative data, in that case, the data that is collected represents an actual label. So you could be looking at red cars, size of shirt, any data that's collected, but it's not actually some sort of a data that you can actually run numbers. Let's talk about other type of data. And whenever they mention that the data happens to be numerical values, in this case quantitative, if they mention discrete refers mainly to data that is numerical and it has a specific characteristic. In this case, it's given by integers. So for example, number of babies. If we're talking about number of babies, you would look at 0 babies, 1, 2, 3, or a given value. You couldn't really have 1.3. It wouldn't really make sense since babies, we're talking about integer values. Now, another type of quantitative data is continuous data. And as we look at continuous data, we're looking at, any data value that happens to be within an interval. In this case, for example, velocity of a car. If we were to monitor the velocity from point A to point B, it's going to be all over the place. At a stop, you're going to be at 0. In the streets, you could go from 0 to technically 45, depending on the speed limit. And then you can go on the freeway, and technically, you could go as fast as you can. You do have limits on the law, but it can be anything within an interval. Another example of continuous data could be weight. Technically, weight changes within the actual, within the actual days or within the day. Because if you eat, you're going to get a little bit of weight, and then after that, something happens and you're going to get rid of some of that weight. Let's take a look at how we collect data and statistics. So we're mainly going to be talking about throughout the semester in terms of observational studies, experiments, mathematical models, and surveys. And for the data in chapter 2 and on, you technically assume that the data is being collected by one of those. So when we talk about an observational study, in an observational study, the researcher plainly just waits for events to actually happen. So for example, if you look at City of Modesto, it's possible that a researcher is trying to look at cars that are being stolen in the city. And if they're conducting an observational study, the researcher just technically sits there and waits for events to happen. Now, when we look at an experiment, in an experiment, a researcher is trying to modify a behavior or something. And in this case, if we look back to the observational study, when an observational study was conducted, given that they're looking at stolen cars, stolen cars is an observational study if they just sit there. But if the researcher were to modify something, so for example, let's assume here that the researcher is from the police agency and they provide alarm clocks, their car alarms, they are looking to see if by providing alarms, that actually has an effect on the reduction of stolen cars. So anything that has to do with an experiment, the researcher is doing something to actually modify the behavior. And in an observational study, they're just collecting data. Okay, so let's take a look at the next one, mathematical model. Whenever we're running a mathematical model, this is a theoretical way of technically collecting data. And let me actually show you this particular one. So the video that I'm about to show you is a mathematical model of a virus.
Basic information.
So let's take a look at this one. This is in fact a hypothetical scenario of what could happen if a virus spreads out. And they're looking at Ebola in this particular one. And look at the spread. So technically every part in red represents an infected area as time progresses. Does it look familiar? Now, what I just shown you, in this case, this is a mathematical model of what would it look like if this were to happen in terms of the spread of a virus. Now, let's look at what actually happened as of recent events. What you're seeing here is data collected, and as of today, this is the most accurate total count. You have this many individuals infected by COVID-19. Take a look at the map. Almost everything is red. You can actually see that, well, it was a different virus. It was a different scenario. But in any case, the mathematical model basically had predicted that all these urban areas would actually be infected by, well, that actual given condition. Okay, let's go and talk about the next data collection process. Okay, so the next one that we're going to talk about is dealing with a survey. And when we talk about n for our class, n is going to represent a number of given values and will be stated, so n represents an actual number. And when we talk about a survey, we're simply looking at, well, a couple of questions, and then, the subject will be actually answering them. So for us, I'm asking you to take a survey for the week 1 preliminaries to see if the classes are actually a good fit. It's the MGC quiz, the online readiness. So that would be the idea. You're given a couple of questions, and then you're just answering them, and then somebody will be collecting that data.